Why stress out if we don't understand? It's easy to think of a million or more reasons why. Designers must have specialized understanding of the components they develop. Modularization feeds an incremental approach to any design process, in addition to teamwork, parallel processing. How we choose to document our design employs both language and language in Chomsky's regards. If we are learning, it is best if we do not get uncontrollably excited. Excitement is otherwise encouraged, like Charles Darwin and Gregor Mendel. Charles Peirce and Ferdinand de Saussure may never have met, but their work gets at the heart of representation and the represented. Can we really understand what makes M.C. Escher print so fascinating and elusive at the same time? Escher was not just a graphic designer, he was also a mathematician. Even though we might not understand how Escher derived many of his designs, we can easily see why these designs hold substance and inspire us. That kind of understanding helps influence our environment to our benefit. With generative artificial intelligence, we might understand our results, but like the Escher print, not the exact origin of the design. Raw inspiration may not be enough to derive a novel design. Claude Shannon, the father of information theory, work explains information theory, which is the basis for neural networks backing modern LLMs or large language models. The statistical properties of natural languages enable algorithmically extending a prompt merely to compute the most likely tokens next, the completion. The underlying neural network has no real human understanding. Shannon suggests we train a neural network to do such work according to the smallest possible unit, that is, the individual letters that make up words. Such units are called n-grams. Most people do not understand that today's LLMs are so powerful because of their size, that is, the number of parameters the model supports. While it may be easy to collect training data, software developers are typically not qualified to engage in fine-tuning an LLM like this, as selected data must be representative. For example, augmenting a model that serves as a multi-class classifier, say to recognize pictures of flowers, must involve the skill of a botanist. Generative AI must be seeded, first to initially train the underlying neural network, then in the form of prompts. These prompts are simply user requests. Generative AI serves as a productivity assistant, freeing us to focus on what makes our designs unique. Can generative AI innovate in this manner? That is, exceptionally innovate? Perhaps not. Is generative AI capable of language cognition that surpasses the ability of human experts? If so, generative AI may be considered an ASI or artificial superintelligence. Most software developers believe that modern generative AI is not an ASI. However, convincing arguments could be made that generative AI is an example of an AGI, or artificial general intelligence, with the emphasis on generality, so far as domain is concerned. Neural network language models, or NLMs, are the basis for many of today's transformer-based architectures. Initial training and periodic retraining requires substantial computing power, or throughput, and a couple gigawatts electricity. Neural networks are utilized as a data structure to engage in free interchange with the user. Just how free this interaction depends on how the neural network was trained, that is, the training set. Generative AI is built with an LLM recognizing patterns as n-grams to form a suitable completion. While NLMs pose many limitations, so long as the training set is representative, overall performance is proportional to the number of parameters the underlying neural network supports. Generative AI should not be trusted to do things for us we cannot do for ourselves, from a conceptual or a design standpoint. A niche implies novelty, an aspect of the design that might not have been discovered by generative AI. Such elements of a successful design might work their way into the refinement of the training set. Nobody would build a robot to go on vacation for them. Cleaning sewers? That is a different picture. Similarly, engineers and scientists do not rely on generative AI to produce finished designs. Knowledgeable technologists can increment development forward, modularize, employing generative AI on a segmented basis.